this a real scary title? It's a real scary title for reintroducing us to A, H, and K. All right? Your H's and K's are coming back. Ladies, come on. Your H's and K come back again. We still have it's the same generic setup as it was before. All we're going to do today is we're going to start with our standard form, our A sine B of x, or A cosine B of x, like we did yesterday. We're going to plot that as what we call the parent function. And from there, we're going to move each one of those 5 points that we found. Remember, amplitude 0, negative amplitude 0, amplitude for cosine, or the other way around for sine. We're going to take each of those 5 points and move them. Okay? And just move them. So if you recall when we had H's and K's before, we would plot a parent function, and each of those points we would just walk the H value or the K value. So what you're going to see today is the same idea. Instead of labeling your A's and B's, we're not only labeling A's and B's, we're also going to label our H's and K's. So the first step here, here's what happens. It's the exact same idea as every other horizontal and vertical shift that we've had before. We have the two functions, y equals A sine B of parentheses x minus h plus k, where this is your horizontal and this is your vertical. Notice again when they have the signs, just like all of the other times that we've done this, our h values and our k values, we're shifting them left and right, and our k values are up and down. Remember, horizontal, vertical. It's the cheesiest way known to man to remember that. And it's the same idea for the cosines. It's the same look. Really, the only difference here today really is it's just a matter of knowing how to plot your domain. What is your domain again? What values go with domains?
Domain A.
X. So, remember, what was the other rule with our h values? Since it's minus h, what was our rule with that?
Positive.
Yeah, change the signs. Okay. So let's say it was x minus pi, that means it's shifted it to the right pi. If it was x plus pi, you'd be shifting to the left pi. Remember, we change our signs. Okay. So the two other things here, I mean, it's we follow the same rules of everything else. What I'm going to do here, instead of changing this, I'm just going to put the second one in for it. Y equals A sine B x minus h plus k. And I'll put this over here for the cosine as well. So those are our two values. Plus, basically, the easiest way to do these things is just to jump right in and do a bunch of examples. There's really no one surefire way of doing it every single time, except for always starting with your parent function. So we're going to start with the parent function every time we go. For example, I have y equals negative 2 plus 3 sine 4 of x. You see what they did there? Yeah. What do they do to the k value? They put it in the front. Okay, just put it in the front. One of the things you will find a lot of times that your h value is always going to be in parentheses. The h value will always be in parentheses for you. Okay. In this instance here, the k value sometimes to get away from any confusion that you might see, since here you see that there's no h value, there's nothing in parentheses, they put the k out in front. So that way you don't assume that there's an h value. Is there an h? So what is it?
0.
If it's not there, what is it? 0. Okay. So here's my A, here's my B. So I start A, 3, B, 4, H, 0, K is negative 2. All right. I start the problem the same way. I go to my A and B to figure out my amplitude. My amplitude is 3. My period is 2 pi over 4, which is pi over 2, very good. And then I start my plot. I know that my period ends at pi over 2. What's half of pi over 2?
Pi over 4.
Good. What's half of pi over 4? You should have stopped eating pie. You guys will miss me for a week, don't lie. No, you won't, I know. I won't miss you either, but that's besides the point. Anyway, now what? The next one is 3 pi over 8.
Over 8.
Okay. All right. My amplitude is 3. My opposite amplitude is -3. You okay with that? This is this was a sine function, so where do I start this parent function? I start at 0. Go to the amplitude, 0. Opposite amplitude, 0. And now remember, when we graph our parent functions, if you don't have 2 colors, what I'd like you to do is draw the parent function as dotted.
Oh, this is a parent. Oh man,
That's the parent function. Ladies, I'm sure it has nothing to do with what I'm talking about. Stop. Now, for each of these points, I take and I worry about my shift. Do I move them left and right?
No.
So what do I have to do to each one of those points?
Down 2.
Down 2. So now I just move each of these points down 2. So instead of being at 0, I'm at -2. Instead of being at 3, I'm at 1. So instead of here, I'm back at 0. Instead of being at -3, I'm at -5. And I'm back to -2. And I just shifted it. I moved each of those points down. I adjusted the scale. That's all you have to do. Okay? That's all you had to do is adjust the scale on that. So now in this graph, you will see that you have the dotted line parent function. And within each of those points, I moved it down 2. Because that was my k value. The k was -2, so I vertically move it down 2. All right? The h was 0, so there was no horizontal, there was no left or right shift. And I just go point by point, and I move it. Okay? Okay? 3 plus 4 cosine 2 of x, or 2x. 3 plus 4 cosine 2x. Once again, your first steps are always label everything that you can. A is 4, B is 2. What's H? And K?
3.
See how they put the 3 out in front again? They're trickers, yes. All they're trying to do is trying to alleviate any tricking, because you don't. If they put that K next to the 2x, you might think that it's the H value. So that's why they move it around. So right now, you can tell me without a doubt that there's no horizontal shift of what's going to happen to every one of these points. It's going to go up 3. So when you do a problem like this, and you already know in the back of your mind that it's going to move a little bit, if you know that it's going to move up 3 to start with, do you see how I'm adjusting my scale right away? I'm allowing for a little bit more space up top. You don't have to do that. It's just a suggestion. You know, if you notice that you're going to have a horizontal shift or a horizontal shift that's further away, you might draw the line a little bit longer either direction. It's just knowing what these values mean. It's a little bit helpful to be able to do. Just in case when you're writing it up on your paper later, you don't get out of space. So it's a cosine function. We have a period. Oh, we got to find our amplitude. 4, and our period is just, we agree it's pi. 2 pi divided by 2 is pi. So here's pi. 0. Pi over 2. Pi over 4. And 3 pi over 4. Is everybody okay with how I'm getting those breaks in the period? Cutting everything in half each time? All right, remember, don't freak out when you have pi in there. You could use the fractions with your calculator and just remember to put pi on the x-axis, okay? All you're doing is finding the averages between the two spots. Cosine functions start at the amplitude. They go to the negative amplitude. So my parent function starts at 4, 0, negative 4, 0, and 4. And remember, dotted. And then what do I do to each of these points? What's that? Perfect. You go up 3. So
Does it get harder today?
tangents are what gets tough.
Well, today does it get harder?
Not really.
Not really. Are we learning tangents?
No. No, I don't like to bring tangents in with sines and cosines because it's completely different. And I want to make sure you guys get this down pat before we get the tangents. So these both these two problems we've just done were just vertical shifts. When you start worrying about vertical and horizontal, that's when things can get a little bit more complicated because you have to start watching your scales in here. No, I'm just going to give you your homework and say it's a quiz.
Okay, cool. I thought you were being serious.
Do you want to do another vertical shift, or you're okay for right now? We're okay, or do you want to just go right to the horizontal stuff? Don't speak all at once. Here we go. Ooh, it's icky looking. Icky, icky.
It's okay.
It's the icky shuffle, if you recall that. What do you think your first step is going to be?
Label everything out.
Label everything out. Good. I am.
Oh, you are.
Yeah, I actually remembered today.
Oh,
Way to go, Murphy.
yeah.
A is 2, very good. B is 2/3, very good. Very good. Is it negative or positive? Good. A is 0. Error 5. Now, the next thing we have to figure out, amplitude and period. Our amplitude
It's 2.
is 2. Our period is going to be 2 pi divided by 2/3.
1/3. 5.
Remember, when you multiply fractions, you're multiplying by the reciprocal. Period's 3 pi. 2 pi divided by 2/3 is 2 pi times 3 over 2. Your answer is 3 pi. When you are doing that in your calculator, can you steal yours real fast, please? 2 divided by parentheses. 2 divided by 3. Make sure you put it in parentheses so you're just going to type in your calculator and figure it out, okay? So I know my period is going to be 3 pi. Bless you. So move this stuff out of the way. It's supposed to work. I know. So now, I go ahead and I'm going to start with my parent function. 3 pi over 2, 3 pi over 4, and then let's see, what do you think that's going to be?
I'm going to say 3 pi over.
3 pi over 8. Is it 3 pi over 8?
It's not. It's totally not.
Well, watch this. When you get down here, when you get in this area for the quarter, that's usually going to be the common denominator for everything else. So this is 6 pi over 4. This would be 9 pi over 4, because this is 12 pi over 4. Okay? Or use your calculator. 1.5 plus 3 equals, divided by 2. Bada bing, bada boom. There's your answer. Remember, each one of these sections, when you're going from here to here, that's the midpoint. 0 plus 1.5 divided by 2. $1.50 and $3. What's in the middle? Okay? That's all it is, guys. That's all it is. Use the calculators if you're not sure how that goes, okay? Now, I start by labeling my amplitude, my opposite amplitude. I don't know why I put 2 tick marks in. Don't need to. And I start with my parent function. It's cosine, right? Yeah. It's cosine, so where do I start?
2.
On the 2. Good. 0, opposite, 0, and 2. And then, okay? What am I going to do to each of these points now?
Move it up pi over 3.
You're going to shift it to the right.
I shift it to the right pi over 4. So here's what happens. When you're shifting it to the right pi over 4, what you need to be able to do is identify your new spots. Okay? We have to be able to identify our new spots that are going to happen. So when I shift it from 0 to the right, pi over 4, what's this then? It's pi over 4. When I shift this point to the right, pi over 4, what do you get? Hi, how are you? When I shift this to the right, pi over 4, what do I get? Well, remember, this is the same thing as 6 pi over 4. You get 7 pi over 4. This becomes 10 pi over 4. This was 12 pi over 4, so it's 13 pi over 4. Yeah, here you would just put, and then you're right, this would be 5 pi over 2. Okay? Remember, your calculator will do this for you. All right? You just have to know how to add fractions in your calculator. And remember, you don't push the pi button when you're doing that. Don't push the pi button when you're doing that, because you're going to get some weird answer. Just keep them as the fractions, and when you're putting your scale in, slap pi next to it. You're going to be okay. Now, does everybody see when you have a horizontal shift, you might want to have a little bit extra space? Space it out a little bit, so you have a little bit of room to work. So now every one of these points is just moved over to accommodate the shift. And I connect them. And there's my new graph. Okay. What's that? Another? Just one. So I have y equals sine of parentheses x minus pi over 2. We always start what's my value for A in this one?
1.
What's my value for B?
1.
What's my value for H?
Pi over 2.
And my K value?
0.
Good. So do I need to worry about adjusting my scale up and down? No. I will have to adjust my scale which direction, right or left?
Right.
How much?
Power
Good. So we start with our generic. Oh, we need our amplitude.
1.
Period.
1 over 2.
Period is just 2 pi. Remember, your period is 2 pi over the absolute value of v. So in this case, it is just 2 pi. So when I go to start my graph, I know I'm going to be shifting it to the right a little bit, so I'm going to end my period here at 2 pi. And just cut it into the corners. And this shift you're going to find out is very, very easy to do. Because your corners are already done in halves. Okay? Our A value is 1. Opposite of 1. Sine function. Where do I start?
0.
0. I'm going to have fun with this one. Because it's, I don't know. You agree?
Oh, it's so cute. Oh, you missed one.
Squint, it goes away. Now, what do I do to each one of these points? Shift it. Which way? Good. So let's see here. Go back. Instead of being at 0, I'm going to be at. Instead of being at 1, I'm going to be at. Oh, excuse me. This one went from 0 to pi over 2, so this one goes from pi over 2 to pi. Here, here, and then what's my ending spot now?
-4.
Ah.
What?
Well, this would be 2 pi.
Wait, how do you go pi?
Very good. 5 pi over 2. Remember, I'm adding pi over 2 to each point. So all it winds up doing is this. It just moved to the right, pi over 2. Your scale in this case really didn't need to be adjusted. All you had to do was add on that last point because everything else was already on there. Sometimes they're easy. I haven't even done one with both of them in it.
You don't need to. We don't need. We'll figure it out ourselves.
I don't remember what you have them. Oops.
There's definitely not a K there, so I don't know where.
Well, let's put a K in here then.
Plus 1.
All right, so we have 8 sine 1/2 x plus 4.
16.
Oh, wait, I need a pi here, don't I? We'll put a pi, 4 pi. And then minus 2. So I made it different for you. And I'll keep pi in there so it's a little easier for you to go.
So,
Take a minute. Try that one. I'll let you try that on your own. All right, let's start looking at where we're at here because we're starting to run a little short. A is 8, B 1/2, H is negative 4 pi, and K is negative 2. Do we agree on that?
yeah.
Okay. Amplitude.
8.
Period.
2. 4 pi.
It's 4 pi. 2 divided by 1/2 is 4 pi. And then everything else is good to go. Now, I know by looking at this right away, I'm going to have to shift everything to the left 4 pi. Since it is a sine graph, where does the sine graph always start?
0.
It starts at 0. So what I'm going to do is this. And that comes with practice. Seriously, it just comes with knowing. If you know what your shift is to start with, you know kind of, should I raise this up higher, lower, move the back and forth. That's all. It's just, you'll get the hang of it, really. So I know that my period is 4 pi. So here's 4 pi. Oh, these are going to be easy ones to work with.
Yeah, it was pretty simple. I feel like I should always be like that.
And then here's 8. Here's everything should be 8. It's a sine graph, so we start at 0,
Yeah.
8, 0, negative 8, 0. All right. From there, everything goes left 4 pi, and then it goes down 2. Here's negative 4 pi. Boy, this is fun. Yeah. Oh. Oh, my scale's a little nasty, but whatever. So now here's 6, and what's the lowest value then?
Negative.
Negative 10. Okay. So this point starts here and goes down 2. This one goes to negative 3, down 2. This one goes to negative 2, down 2. This one goes to negative 1, down 2. This one goes to 0, down 2. There it is. It's very pretty. It's almost like a Russian accent. Okay. Scary?
One more. Yes.
Okay. I'm going to give you a couple of these to work on for tonight.
Oh, I get it.
Oh, I left the page back here. It's on page 845. Wow, that's a long way away. Bless you.
1 through 2. 1 through 2 even.